Hello Internet, welcome to another tutorial in Digital Electronics series. In today's tutorial, we'll talk about a very important topic, which is bit rate versus baud rate. Now this topic is pretty easy, but there are some misconceptions and myths about the differentiation of the two terms that leads to a lot of confusion among students. So we'll clear all that in today's tutorial. Now, when we talk about bitrate and baud rate, we need to understand two key terms. First, the first key term is data element. Now, in digital communication, when we send data in terms of ones and zeros, the smallest piece or the unit of information is a 0 or a 1. So a data element essentially consists of zeros and ones, which is known as a bit. Any meaningful symbol, any meaningful signal will be constituted of bits. Please understand, a single bit would not make sense in most cases. For example, if you wish to send a character, you will need to send 7 bits of data, which is the code length for ASCII code. So please understand that data element is the smallest piece or the unit of information that may or may not hold significance if it is sent as a data element itself. And the next thing is signal element. It is the smallest unit of signal, which makes sense. For take up examples of meaningful signals, ASCII code is one signal element which has 7 bits of data elements. Similarly, BCD is another meaningful signal element which has 4 bits of data elements. And depending upon a lot of situations, you'll find that the signal element will constitute a number of data elements. For example, when you do quantization, and if you choose a 128 level quantization, then you get a 7-bit code length from 0000000 to 1111111. So each of these signals, each of this sample, which is known as one signal, one meaningful signal, will have to carry 7 bits of data. And if you were to use 512 quantization levels, then the signal length will become 9 bits, depending upon how many bits are required to carry one. So moving on to define bitrate and baud rate, we can say bitrate is the data rate, which is denoted by capital R, and it simply signifies how many bits are being transferred per second, not essentially the signal elements. And baud rate will be the signaling rate, and it is denoted by a small r. And of course the small r is related to capital R, like this, where n is the number of bits in a signal. It is easy to comprehend with an example. We want to transmit BCD numbers. So if the data rate is 1000 bits per second for, let us say, BCD numbers, so 1000 bits are being transferred per second. That would mean that each BCD number is 4-bit long, so 250 BCD numbers will transmit in 1 second. So considering one BCD number as one signal, so the signaling rate will become 250. However, the bit rate was 1000 and bit rate would be the data rate of how many bits are transferring per second, and baud rate is how many signals are being transferred. So 250 meaningful signals, 250 BCD numbers were being transmitted in 1 second. So the baud rate becomes 250 and the bit rate becomes 1000. And it is a fact that baud rate can never be greater than the bit rate. It can at most become equal to bit rate, where one signal element constitutes of just one bit. So having understood this concept of the signal element which constitutes the data element, which is bit in digital communication, we can now proceed on to solve these numericals. The first numerical says an analog signal has bit rate of 8000 bits per second and a baud rate of 1000. So we know that capital R is 8000 and the baud rate is small r is 1000. So we need to find how many data elements are carried by each signal. So we need to find n. The relation is 1000 is equivalent to 8000 by n from this formula, and n becomes 8. So this is an example of one such signal which constitutes 8 bits to make one meaningful unit. And the second example is an analog signal carries 4 bits per signal element. So n is 4. If 1000 signal elements are sent per second, small r is 1000. We need to find the bit rate. So the bit rate r will become 1000 into 4. So r will become 4000 bits per second. So this is how the bit rate and baud rate are related to each other. They totally make sense once you understand how many bits are constituting a meaningful signal. The signal could be made up of 1 bit, 2 bit, 3 bit, 7 bit, 9 bit, any number of bits, and that would decide the baud rate of the transmission. And I hope this tutorial was of help. If you like the content of the video, give it a thumbs up. I'll see you in the next one. Take care. Bye bye.